Okay, I hope this is a reasonably short video. I wanted to finish up talking about lists. And one subject that often comes up is how to sort a list into some given order, assuming it's got something in it that a key in it that you can sort on, like a number or a text, since that can be sorted in lexicographical order, like in a dictionary. So, how do you sort a list? Well, there's a couple of approaches to that. Let's construct an example list. Let me run my file over here. So I've got a list T, and it's not too exciting to sort it. So let me mix it up. So let me do import random from random import shuffle. Okay, so shuffle is kind of weird. Let's see, you shuffle take shuffle of the list, or whatever you're going to shuffle, and then hit it. It doesn't return anything as you might expect it to. You might expect it to return this shuffled list, but it doesn't. What it does is shuffle the list in place. So it destroys, if you had some copy you wanted to save, then it just destroyed it. So you have to make a copy first. Okay, so if we want to sort that list, how do we do it? Well, let's make a copy. Let's let S be T.copy. Is one way of doing it. Okay, so there's two ways to sort a list. There's a function called sorted, which is let's take a look at the documentation on that. Python 3 sorted. And there's, let's see. Okay, sorted, here it is, returns a sorted list from the items in iterable. Right now that's going to be our list. I'll explain in a few minutes what an iterable is. There's two optional arguments that need to be specified with name. One which is a function of one variable to get a comparison key from each list element if it's not obvious, and then true or false to get the list sorted in reverse order. So let's go back here. In this case, the list elements are their own sort keys. So if we say R equals sorted T, T. T, but remember what T is. It's up here. It's not in order. So we do R equals sorted. So R is then a sorted version of T, and T has not been changed. So that's sorted. Let me get into the keywords, the arguments and stuff a little bit later in a few minutes. Okay, the other way to sort a list, which seems almost the same but has important differences, is that the list class type has a method called sort. And it takes the same sort of argument, so you could say T.sort, but there's the one difference is that sorts T in place. So if you had data in T, you didn't want to have it all destroyed, it just destroyed what's in T, or maybe that's good that it sorted it in place. So it sorts it in place, which is different than when sorted does. So you have to choose what you want to do there, and which is the relevant function to your problem. As for the sort keys, let's look at my crude database over here. So there's some names together with some exam scores, let's say. I'm just doing the names as first names just to make keep it short. So I might say, well, that's not sorted on by name, and it's not sorted by score. But it doesn't make sense to compare one of these things to another. If you take Alice's data. I just did the wrong thing for copy because I can't remember I'm on a different operating system. So you do, is that less than Bob 85? And you know, I just did it again. Ingrained habits are hard to remember to overcome. Okay, and true. Is that what you wanted? I don't know. So it's not clear what it's doing there. So one would like to choose to sort this data list by name or by score. So let's sort it by score, and we need to sort. What we need is a function that will return the score from one of these data elements for a name, which is the second argument. So I can just say, let's say def, what should we call it? R score, return score of some list like that, X. And all you want to do is return the second element, which is x1. You'll remember it starts with 0. And that's it. Oh, I see. I misspelled def. And if you think this is atypical of what happens when you're programming, you'll find out that's not. Okay, so what we could do would be, let's say, so let's get a sorted list. Let's say S data, sorted data by score is, let's say, sorted data key function is R score. Okay, now what happened? S data, if we look at it, printed it. It sorted it, but in reverse order. That wasn't too good. So let's see. I'm not sure what. Oh, it did. No, I'm sorry. I did it wrong. It sorted it by score in ascending order: 69, 74, 85, 88, 100. If you don't like that order, let's take the same thing, and then here we can say reversed equals true, capital true. Is that how you spell reversed? Excuse me while I check sorted, reverse okay. I need top of the line electronic help for spelling. So let's say reverse equals true. It's a Boolean. So now if you look at S data, it's sorted in a descending order on the score. 100, 88, 85, 74, 69. If you want to sort on the names, then you have to define a function to give you the first name. And here's a little trick. This is a good opportunity for it. Is let's say n data equals sorted data. Excuse me, I don't need that. Data. Key, what's the key function? Well, rather than defining one above, let's note that this function gets called probably once, and I don't really need a name for it or store the name in memory. I just need a one-off function that can do it. Well, okay, for a simple function you can do a lambda expression. So lambda x colon x of 0. And that's it. That's the function. Okay, so what the heck is going on here? What does lambda x mean? Well, this is looking back to the lambda calculus, which was a big thing in mathematical logic in the 20th century, and it's still a big thing in computer science. So you have to, eventually you would study in computer science lambda calculus. So in this case, we're following the notation of that body of work, which was just, this is a lambda just tells you this is a function, and I'm about to tell you the variables. So the variables, in this case, is one variable x. And then there's a colon, in which I'm about to write, in which I write an expression that will return a value. And the return value of this function will be the value of that expression. So there's just one expression. So in this case, it's x of 0. It will return the value of x of 0. Okay, that's the function. Then I want to move on to the next parameter, which I don't need. So let's just do that. Okay, so let's see what happens. N data. I got sorted in ascending order by name. And then, of course, we could use the reverse parameter to sort it the other way. Let me just copy that call to sorted above. Keep typing the whole thing. Wow, I did a copy Windows away without using something from Linux first. Okay, so let's add the reverse parameter equals true. And there it is. Okay, well, I promised I was going to say something about iterables, and let's do that. You should remember, of course, before I do that, that there's many different sorting routines that have been ways to sort data in memory that have been studied, and some of them are, faster than others depending on how much data there is. So it's not clear what sorting algorithm is being used. Well, it's an algorithm called Tim sort, after the guy who invented it, Tim, and it's basically, for those who know what I'm talking about, an O of n squared sort. So there is a call sometimes for more sophisticated sorting routines. Okay, well, I was going to promise something about an iterable. Let's see if we can say about that. So, return a new sorted list from the items in iterable. What's an iterable? Well, something is iterable if it can be iterated. So an iterable is some kind of object that it's a collection of some type. You can go over and iterate elements from it. It may not be clear how to do that. How to get the elements. So this is making it easy for you. So there's a iterable protocol which such an object has to follow. If it follows, then you can use it in all these places. It says iterable. And sort of the litmus test is whether you can use for to go over it. So in the case of a list, you can say for x in, where is it? T, print x. So that went over everything in the list. So a list is an iterable, and it comes out in the order of the indices, which is what you'd expect. And another iterable is a string. So print x. Okay, so it's printed all the characters, and this is in the string in order. Notice it printed the space characters too. Okay, and then of course the other one we know now that's big is a range, for x in range 10. Print x. So a range it's sort of like a list of the numbers specified by the variables, and you iterate over the list, although it doesn't actually construct a list, which is good if you've got a million things to iterate over, and that can easily happen in some programs. Okay, so an iterable is something you can use a for loop on, and all these other operations. So it's good to remember a list is an iterable, a string is an iterable, a range is an iterable. And let's see what you can do with it. So up here, built-in functions. Let's try help on list. So let's just get rid of this and go back here to Python 3 list methods. Okay, so here's the list methods. You could append something to the end. You could extend it by asking this iterable to list all of its elements, and then you can they'll extend it by adding them to the end of the list. You can insert an item at a given position. You can remove an item by the value of the item. You can do pop. This means I is optional, and it returns the ith element and removes it. I'll talk about that in a minute. Clear all the items from the list. Index, find the index of x, count the number of x's, sort, we talked about, reverse, reverses it, copy, we talked about, and so on. So these make sense. Again, I'm not going to go through each one of them by as an example, but you should know about them and have some idea. Oh yeah, you can do that with a list, so I'll look it up and do that. Okay, where does this crazy pop thing come from? Well, let's go back to here, and I think I have a list S, right? Okay, that wasn't sorted though, so I got T is presently sorted, good. Okay, not that it matters, but I was going to talk about pop. So what happens if I do pop 3? Okay, the third element of the list is 0, 1, 2, 3, says 3t. So this pop function, oh yeah, I'm sorry, t.pop, it needs to know what list I'm talking about, pop 3. And the answer is 3t. And t has been changed by removing that answer. Okay, why do they call it pop? Well, if you don't give a value to list, it returns the last value and removes it from the list. So an important data structure in computer programming is a stack, and a physical analogy they usually use is one of those things you see in cafeterias where you have a stack of plates on top of a spring, and if you put more plates on it, it pushes it further down. You take a plate off of it, it comes up a plate. So it always has the last thing you inserted is the top thing in the plate dispenser. So if you take a plate off of it, it comes up one, and that is so that you get a next element. That operation is called pop. And the converse operation is push, where you put a new plate or a bunch of new plates on top of it. Let's say one new plate, and that makes the list go down by one new plate. So you can easily implement a stack in Python by doing a list, and you pop off the last value. You pop off, just say pop to get the last value, and if you want to put something on, well, it's not called push, it's called append, right? Append 4. So I pushed a 4 onto the list, and then I could push a 5 onto the list. As I say, it's not called push, it's called appendix. Append, not appended thing. 5. So I push a 5 on it. So the top of the stack of plates is the plate numbered 5, and then if I do pop, t.pop, I don't have to say which thing, then I get to take off the top element of the stack and return it. Okay, so it's easy to implement a stack data structure using those two functions. It would be possible to have a synonym for append as push. It's a little bit difficult to do that. I'll see if I can figure it out. You could also think I could implement a queue, or you put something on the front and then take the thing off the back when you take something off the back, and that would be called a queue, and that would be is another important data structure. However, it's not good to implement it with a list because if you put something on the front, all the list elements have to move up by 1, so that could be a long, kind of a long operation. So there is a module that comes with standard with Python that gives you how to implement a queue and a DQ, double-ended queue. So this is a little bit more advanced stuff than we've encountered here, but I wanted to tell you why it was called pop. Otherwise it's confusing. Okay, well, I think I've covered everything I wanted to cover in this video, so I will sign out on this, and we'll see you in the next video, or you'll see me. Okay, signing off.